Okay, solve the following equations algebraically. Let's start with problem number 31. We've got -5 times the absolute value of 4x minus 3 plus 7 equals 2. I'm going to rewrite it over here. Now we want to isolate x. We want to solve for x, so we have to work from the outside in, peeling back some of these layers, as I like to think about it, in order to get to x. Okay, we want to start off by peeling back this plus 7. So let's subtract 7 from both sides to get rid of that. This cancels out. We're left with -5 times the absolute value of 4x minus 3 equals -5. Please note that we do not want to distribute the -5 into the absolute value. We want to solve for x, get it by itself. So don't want to do that. Since we're multiplying -5 to this absolute value expression, let's do the opposite of that, which is divide. Divide both sides by -5. We're left with the absolute value of 4x minus 3 on the left side, and on the right side, -5 divided by -5 is 1. There are two numbers that have an absolute value of +1. The absolute value of -1 is 1, and the absolute value of +1 is 1. For that reason, this 4x minus 3 could be equal to -1, could also be equal to +1. So we're going to have two solutions. Okay, solve for x for both equations. Oops. One of our solutions is going to be x equals 1/2. And then the other one is going to be x equals 1. This is for number 31. You can always check that your solutions are correct by plugging them back into the original equation, verifying that they make your equation true. Okay, let's do 32 off to the right. I'm going to rewrite it. We've got 2 times x minus 1 squared minus 5 equals 13. There's a couple of different ways you could go about this problem. You could expand x minus 1 squared, multiply that out, and then take your 2 and distribute it and combine like terms. And if that's the way that you want to approach it, please go ahead. You should still get the same solutions as if we do it this way. The way that I'm going to do it is to, kind of like in 31, peel back some of the outer layers to get x by itself. So I'm going to start off by adding 5 to both sides. Okay, and then I'm going to divide both sides by 2 to get rid of that 2. 2 divided by 2 cancels out. I get x minus 1 squared equals 9. I can take the square root of both sides. The square root and the square cancel. X minus 1 could be equal to +3 or -3 because not only is 3 squared equal to 9, but also -3 squared is equal to 9. Add 1 to both sides. X is equal to 1 plus or minus 3. 1 plus 3 would be 4. 1 minus 3 would be -2. Okay, so two solutions. Again, you can check that they're correct by plugging them back into the original equation. And last but not least, we've got one more equation. X plus 1 equals 2 over x. Okay, we don't want fractions in our equation, so we can take the denominator in this fraction here, x, and multiply each term in the equation by x. So that's going to be x squared plus x equals 2, because these x's cancel out. So no more fractions. That's good. Let's get all the terms on one side and have this equation set equal to 0. X squared plus x minus 2 equals 0. From here, we've got a couple of different options. We could use the quadratic formula to solve for x. We can factor and use the zero product property. You could even complete the square if you wanted to, although I wouldn't recommend that one because you've got an odd x term. Let's try factoring. So I'm using a generic rectangle and a diamond to factor. Let's see, I put my x squared term and my constant term in opposite corners of the rectangle, and then I multiplied them together to get the top term in the diamond. The x term goes at the bottom of the diamond, and now I'm looking for two terms that add to x but multiply to negative 2x squared. And that would be 2x and negative x. I put those back into my rectangle, and I find the dimensions. That's x minus 1 times x plus 2. So I can rewrite my equation as x minus 1 times x plus 2 equals 0. I can use ZPP here. If x minus 1 times x plus 2 equals 0, then either one of those expressions has to equal 0. And if I solve those two equations for 0, I get x equals 1 and x equals negative 2. Plug those back in and you'll see that these are correct.